Assalamu alaikum students. Today we are going to learn about system and control volume. A system is defined as a quantity of matter or a region in space chosen for study. So system is something that you choose for study. It can be a quantity of a matter or a region. For example, you can choose to study an engine. So engine is going to be your system. Or you can choose to study flow in a river. So river is going to be your system. If you want to study flow behavior in a room, then room is your system. Now, any system is going to have two things. It is going to have a boundary as shown in this figure, and it is going to have some surroundings. Now system can influence the surroundings through the boundary, or system can be influenced by the surroundings. Just think about an example of a balloon. If you fill a balloon with air, balloon expands and it takes the space from the surroundings. So in that case, system is affecting the surroundings. You let the uh, air come out of the balloon. Now this air, the mass of the air is entering in the surroundings. So here the system is affecting the surroundings. So system can be influenced by the surroundings and system can influence the surroundings, but your system must have a boundary from which the mass or energy can be transferred to the surroundings. As I said, the system is going to have a boundary. This boundary can be fixed or can be a moving boundary. If you look at here in this figure, this one is a typical example of a moving boundary. There is some gas which is filled inside a cylinder. Gas expands and it makes the piston move in that direction. In that case, the boundary is moving. Now the system can be an open system or it can be a closed system. Closed system can be called as closed mass. As it is clear from a closed mass name that the mass cannot be transferred in or out of the system. But here you need to remember one thing, that mass cannot be transferred in and out, but energy can be transferred in and out of the system in case of closed mass system. There can be a special case which is called as isolated system. Isolated system where neither mass nor energy can be transferred in and out of the system. The other type of the system can be an open system, or it is also called as control volume. Now open system, as it is clear from the name that it is open and mass can be transferred in and out of the system. Or energy can be transferred in and out of the system. So control volume is basically You can say a subset of a system which is called open system. As I said earlier, a system must have a boundary. In some cases, it can be a real boundary, as is clear here from the piston. The gas is encapsulated by cylinder and the piston. So it's a real boundary. The system has a real boundary. But a system can have an imaginary boundary as well, as shown here in this figure where a nozzle is being shown. Now this nozzle have a real boundary, this one, but we have to bring in imaginary boundary here, as it is being shown here with the dotted line, and then I have highlighted it with the green line. In reality, there is no boundary there. The mass energy can flow from the nozzle, but when we are going to analyze it, we have to make a fictitious boundary there, and we call it imaginary boundary. So as I said earlier, the system is going to have a boundary for sure. It can be a real boundary or it can be an imaginary boundary, but it has to have a boundary. Now you are the one who decides about the system, so you define the boundaries of the system as well. Maybe you decide to analyze, okay, I want to analyze half of this nozzle. So you bring in imaginary boundary here. Say just half. Okay, this is your imaginary boundary. That one. Because you are the one who decides about the system, so you chose the boundaries of the system as well. A system is going to have something. For example, for a room, it is going to have an engine or other things there in the room. So quantity is the property of a phenomenon, body or substance, where the property has a magnitude that can be expressed as a number and a reference. So the things that you need to remember here is number and reference. There are some 7 base quantities which are length, mass, electric current, thermodynamic temperature, amount of substance, and luminous intensity. These are the 7 base quantities. Now these quantities can be represented by a dimension, where a dimension is a physical variable used to specify the behavior or nature of a particular system. For example, length has a dimension L, mass has a dimension m, force has a dimension F, time has a dimension T, and temperature has a dimension T, where T is for temperature, it is uppercase T. Now there can be primary or functional dimensions. For example, mass, length, and time. These are the primary dimensions. They don't depend on other dimensions. While there can be derived or secondary dimensions. For example, velocity. Velocity has a dimension of m over t. Similarly, energy is the derived dimension. Now this dimension is going to have some unit, which is a real scalar quantity defined and adopted by the convention with which any other quantity of the same kind can be compared to express the ratio of the two quantities as a number. This definition looks quite cumbersome. Let's think about length. Length has a dimension L, and we say it has a unit meter. Now meter is something that we have adopted, and it is a standard length of something which is placed in France. Now we compare this unit to find the length of different objects. Let's suppose we say a table is 2 times of 1 meter. The 1 meter, the standard which is placed in France. So we compare the length with the standard, and we said, okay, this one has 2 meters length. This table has a 2-meter length. Or if you think about mass, for mass we use units kilograms. So kilogram is again a standard that we have adopted. Again, the standard mass of 1 kilogram is placed in France, and we use that standard to compare the mass of substance. Let's suppose a bucket of water has a mass of 2 kilograms. But we are essentially saying that it has a mass 2 times of the standard mass which is placed in France. Same goes for temperature. So unit is something that we adopted, and then it is established as a standard worldwide. As you all know, there is System International Standard, which is where the mass is kilograms, is represented in kilogram. There is British Standard, where mass is represented by pounds. Now, if you think about the unit of length, it is meter, which is represented by lowercase m. So length is represented by lowercase m. This m is unit, meter. Now the mass has a dimension of m. So this one is unit, the other one is dimension, and both are written as lowercase m. How do you differentiate whether it is m is representing meter or m is representing dimension of a mass? I have written some examples here. Unit of current, what it should be. This red A or a green A. Amount of substance, what should be the unit? Red mole or green mole. Unit of time, green S or red S. Now there is a standard to write these units or Dimensions. Just remember, units are always written as non-italics and dimensions are always written as italics, as it is shown here. Dimension L is italics, unit meter is non-italic. Dimension of mass M italics, units kilogram non-italic. Dimension of temperature T italics, units of temperature Kelvin is non-italics. So this is the convention that we use to represent or write dimensions and units. Next thing is about adding the quantities. Remember, to add the quantities, dimensions have to be homogeneous. And when I say homogeneous, mean it has to be same. If you look at this thing which is being written here, E is equal to 25 kilojoules plus 30 kilojoules per kilogram. Can you add it? Of course not, because the units of 25 is kilojoules, which is energy, and this kilojoules per kilogram, it is latent heat of fusion. So you cannot add these two. Now, how can you add it? Either you multiply this with kilograms. For example, there is something that has a latent heat of fusion of 30 kilojoules per kilogram, and the substance that you have is basically 10 kilogram of that substance. So you multiply it with 10 and you get 3 kilojoules. That's the energy it has, and then you can add these two when they have the same units. Next thing is, you can find the formula using units. Let's suppose you have something that has a density of 350 kilograms per meter cube and it has a volume of 0.1 meter cube, and you want to determine the mass. So mass is going to be density times volume, because density is kilograms per meter cube times meter cube. Meter cubes cancels out with meter cubes. You end up with kilograms, which is the mass, units of mass. So from units you can find out the formula as well, which is this. So mass has a formula rho times V. Next thing is the problem solving technique. There can be two ways that can be adopted. One is the hard way, where you just try to go to the solution. And there is an easier way where you just try to solve the problem in small steps. So these small steps are these 7 points which are being shown here. The first point is the problem statement. The first thing that you need to make is a problem statement. Let's suppose the problem statement that I just decide here is that you want to determine the flow in a pipe. So that is going to be your problem statement. You want to determine the flow behavior and flow rate in a pipe. So you have written your problem statement concisely that you want to determine the flow rate and flow behavior in a pipe. Next thing that you do, next step is you need to draw a schematic. So we just draw a schematic here that okay, this is the pipe. And there is some fluid which is flowing in it. Next thing is the assumption and approximations. You need to make some assumptions. Let's suppose that this pipe is pressurized by some forces. Like this pipe is outside in the atmosphere and there is some atmospheric pressure there. Now there is some pressure which is acting here, there is some pressure which is going to act at the bottom. You can just assume that okay, I assume that there is no pressure which is acting on these sides. Or you can say okay, this pipe, both sides, this is open to atmosphere. So there is atmospheric pressure here and there is atmospheric pressure here. Next assumption you can make that okay, the fluid which is flowing through it is incompressible. So this is the second assumption that you have made. If you look at what I have drawn here, there is quite a sharp edge here and it is quite a nice bend here. You can just assume that okay, the losses at both bends are going to be same. So this is the assumption that you have made. Now let's suppose this pipe is made of stainless steel. So there is going to be some frictional losses. Okay, and you just look at the table and you say okay, this one is going to have friction factor of 0.1. You just approximated it. Rather than finding it by yourself, you just approximated the frictional factor. So you make these kind of assumptions to simplify your problem. The next thing is you see which governing laws are applicable for your problem. Thus, I say that there is a mass which is being transferred through the pipe. So one governing law that I'm going to use is conservation of mass. The mass is going to be conserved. There is another conservation law which is conservation of energy. I say that okay, I just make an assumption there is no energy transfer, so I don't use conservation of energy law. So I just made some selection of that, okay, which laws are applicable for my problem. I just said okay, for this problem conservation of mass is enough. After completing the physical laws, you look at the properties. So properties are going to be what are the dimensions of this pipe, how much is the length of this pipe, what is going to be the diameter of this pipe, what is going to be the density of the flowing fluid, what is the atmospheric pressure there. So you find out the properties, relevant property that you are going to use for your problem. Since you have done these things, then you do the calculations. You apply the physical laws and you do the calculations. And you find out flow rate and the flow behavior. But is it enough? No. You need reasoning verification that whether what you have done is correct or not. Let's suppose there was 2 kilograms of water that entered in the pipe, and from the other side only 1 kilogram has came out, and the flow rate was mass flow rate was 2 kilograms per second. So for this piping system the mass flow rate was 2 kilograms per second. In 1 second 2 kilogram fluid entered, but 1 kilogram has came out. So where the 1 kilogram has gone? No, there must be something wrong, because conservation of mass states that mass has to be conserved. So it means you are missing something in your calculations. Now let's suppose you have done it and you found out that okay, the mass flow, uh, the volume flow rate is 2 meter cube per second. So this is something that you determined, and it satisfies the conservation of mass. So in terms of reasoning, it seems okay. Conservation of mass is there. The 2 kilograms entered, 2 kilograms has gone out, and you have found the mass volume flow rate of 2 meter cube per second. But you need to verify it. that whether it is correct or not. So you verify by comparing your calculations with the benchmark calculations. And then after verification you discuss it. So that's how you can solve a problem by dividing it into small steps. And these steps are problem statement, schematic illustration, assumptions and approximations, physical laws, properties, calculation, and verification. And after that, you go for discussions. The next topic is accuracy, precision, and significant digits. So accuracy of a set of measurement refers to the closeness of the average reading to the true value. So what it essentially means is like, for example, in a pipe, there is a true mass volume flow rate of 2 meter cube per second. That is the true value. You use some measurement device and you found out 2.01 meter cube per second. So it's the variation is less than 1%. The result is quite accurate. So your set of measurements are quite close to the true value. So accuracy is generally associated with repeatable fixed errors. Now the precision error is precision first of all is a set of measures refer to the fineness of the resolution and repeatability of the instrument. Precision is generally associated with unrepeatable random errors. To explain this, there is a small example that I use. Now, for example, you have two anemometers, A and B. You use both these anemometers to take 5 wind speed readings. So anemometer A gives you 5 readings which are 25.50, 25.69, 25.52, 25.58 and 25.61 meters per second. You find the average of all readings which is 25.58 meters per second. If you look at the readings here, these readings are quite close and it has a maximum difference of 0.11 meters per second. So you can say an anemometer is quite precise. The difference is 0.11 meter per second. Now look at anemometer B. It gives you 5 readings 26.30, 24.50, 23.90, 26.80 and 23.60. You take the average of this and it turns out to be 25.02 meters per second. But the maximum difference between the readings is 3.2 meters per second, which is quite high. Now anemometer B is not precise. Anemometer is precise. But which one is accurate, we have to compare it with the true value. So the true value is 25 meters per second. Now compare this true value with the average value of anemometer A and average values of anemometer B. Anemometer A was 25.58 meters per second, which was 0.58 meters per second off from the true value. Anemometer B, its average value 25.02 is quite close to the true value, which is 25 meters per second. So Anemometer B, although it gives you the value which is quite close to the true value, but it is not precise because the values between different readings are, are quite different, and there is a maximum difference of 3.2 meters per second. So anemometer B, although it gives the value which is quite accurate, but is it reliable? On the other hand, anemometer A, the values are precise, but it has an error, and this error is called bias error. Now you can remove this bias error by calibrating anemometer A. So that's it for today, and now I like to you can ask me any question if you like. Thanks a lot.